How long would it take to reach Andromeda? What if we left Earth, left the sun behind, and followed a straight line through space, never stopping until we reach the next great galaxy? It sounds simple, until we realize what that really means. Andromeda, our neighboring galaxy, is the most distant object we can see with the naked eye, a diffuse smudge in the night sky that holds trillions of stars. It's so close that, in cosmic terms, we can call it a neighbor, but close, in the universe, is a relative concept. Andromeda is 2.5 million light-years away, and that's a journey no human spacecraft could complete, at least not with the physics we know today. From an astronomical standpoint, Andromeda is a barred spiral galaxy, very similar to the Milky Way. It has about 1 trillion stars, twice as many as our own. It's so large that if you could see it up close, it would take up more of the sky than the full moon. We just don't notice because it's absurdly far away. That distance, 2.5 million light-years, means the light we see from Andromeda today left there when the first human beings didn't even exist. Every night you look up and spot that little luminous blur, you're seeing the deep past, an echo of a time when Earth was inhabited only by prehistoric creatures. But how much is 2.5 million light-years exactly? A light-year is the distance light travels in a year, moving at 300,000 kilometers per second. That's almost 9.5 trillion kilometers per year. Now multiply that by 2.5 million. The result is a number so large it completely escapes human intuition. 24 quintillion kilometers. It's a distance so immense that no map, no chart, and not even our imagination can portray it realistically. To make sense of this, just look at the fastest spacecraft humanity has ever built. Voyager 1, launched in 1977, is the most distant human-made object from Earth. After nearly 50 years of travel, it has covered about 24 billion kilometers. That sounds like a lot, but it's almost nothing. That distance equals only 0.002 light-years. In other words, in half a century of travel, Voyager has covered less than 1/10,000th of a thousandth of the way to Andromeda. If it kept cruising in a straight line at the same speed, it would take more than 37 trillion years to get there. And just for comparison, the entire universe is about 13.8 billion years old. In other words, even if the cosmos lasted thousands of times longer than its current age, Voyager would still be en route, crossing the emptiness between galaxies. But what if we could travel faster? Let's imagine a few possibilities using speed science has already conceived, or at least dreams of achieving. The speed of light is the maximum limit allowed by the known laws of physics, 300,000 kilometers per second. Even at that speed, it would take us 2.5 million years to reach Andromeda. That means if a ship left today and somehow reached light speed, by the time it arrived, humanity might already be extinct. The crew of that ship would never see the arrival. The mission would be a legacy left to a civilization that might not even exist anymore. But we don't have to stick to theory alone. Let's imagine that in the future humanity masters more advanced technologies, like fusion engines, laser propulsion, or even a warp drive inspired by the equations of Mexican physicist Miguel Alcubierre. A fusion engine could accelerate a ship to about 0.1% of light speed, which is 300 kilometers per second. That sounds incredibly fast, but even then it would take 2.5 billion years to reach Andromeda. At 1% of light speed, 3,000 kilometers per second, the trip would drop to 250 million years. And at 10% of light speed, 30,000 kilometers per second, it would take 25 million years. It's striking how, even when you multiply the speeds by 1,000, the time remains unimaginable. Now imagine we someday manage to build a warp drive, a ship capable of distorting the space in front of it and shortening the path between 2 points. In Alcubierre's theory, space-time could be compressed ahead of the ship and expanded behind it, allowing it to move effectively faster than light without violating the laws of physics locally. If it were possible to travel at 10 times the speed of light, the journey to Andromeda would take only 250,000 years. Even so, that's far longer than the entire history of human civilization. It's a reminder that the universe is simply too large for the pace of our lives, and perhaps even for the pace of our species itself. But before we got there would be another challenge: the space between galaxies. Between the Milky Way and Andromeda lies a colossal void known as the intergalactic medium. It's a place almost completely devoid of matter, a region with fewer than 1 atom per cubic meter. Along that route, there are no stars, planets, or nebulae. A ship would travel for millions of years in complete darkness, surrounded by near absolute cold, with temperatures close to absolute zero. It would be a solitary, silent voyage, without any visual reference for entire ages. For millennia, the only landscape would be nothingness, until, after millions of years, a faint smudge of light would begin to grow on the horizon. That galaxy, despite looking static in the sky, is moving fast. In fact, it's coming toward us at about 110 kilometers per second. That means that while you watch this video, Andromeda is drawing closer to the Milky Way, little by little, but inevitably. Astronomers estimate that in about 4 billion years, the two galaxies will collide and merge into a new gigantic structure that some call Milkdromeda or Lactomeda. But that collision won't be like an explosion. The space between stars is so vast that most of them will simply pass by one another without touching. What will change is the shape of the galaxies. The spiral arms will distort, and Earth's sky, if Earth still exists, will be filled with hundreds of billions of stars. And after billions of years, everything will settle into a single elliptical galaxy, the result of two cosmic neighbors fusing together. Curiously, this means that even without building a ship, Andromeda will come to us. One day, the light of its stars will fill the night sky. Humanity, or whoever is here, will see the universe with different eyes. In a way, that future merger is our set date with the rest of the cosmos. But thinking in these scales confronts us with something much larger than science: the very notion of time. For us, time is what passes between a sunrise and a sunset. For the universe, time is the span between the birth and death of stars. When we talk about journeys lasting millions of years, we stop talking about human projects and start talking about entire civilizations, about continuity, about the almost stubborn desire to endure. A ship bound for Andromeda wouldn't be just a scientific expedition. It would be a time arc, a symbol of human curiosity turned into legacy, traveling through space long after Earth ceased to exist. It's striking to realize how our current technology barely scratches the surface of this challenge. Voyager 1, for instance, travels at about 17 kilometers per second, and even so, it took 40 years to exit the heliosphere, the limit of the sun's influence. That's less than 1/1000th of the way to Andromeda. Even if humanity managed to build a ship 1,000 times faster, it would still take millions of years. The universe is vast, and perhaps that's its way of teaching us humility. But there's something poetic in all this, because even if we never physically reach Andromeda, Earth's light is already on its way there. All the radio, television, and other transmissions we've emitted in recent decades are expanding through space. They travel at light speed and will one day cross intergalactic space. In 2.5 million years, those waves will reach Andromeda. Perhaps sooner, since it's coming toward us. If someone is there, now or in the distant future, maybe they'll be able to pick up the first echoes of our existence. And even if no one is there to listen, it means that a part of us, however invisible, is already en route. As we speak, our civilization is, in a sense, traveling to another galaxy. Thinking about this changes our perspective. Sometimes we imagine the universe as something distant and unreachable. But in cosmic terms, we're all connected, pieces of the same gigantic structure, slowly moving toward one another. Andromeda's light has been traveling to us for millions of years, and our light travels back. It's a silent dance, a message exchange between two galaxies separated by space but united by time. So, how long would it take to get to Andromeda? With today's technology, the answer is simple: far longer than the universe has even existed. But that question goes beyond physics. It's a reminder that the cosmos is made of magnitudes that surpass any human limit, and that our curiosity is the only force capable of trying to reach them. In the end, maybe the trip to Andromeda doesn't need engines, but imagination. It's what lets us cross the impossible, see the invisible, and turn unattainable distances into stories. And as long as there's someone looking at the sky and wondering what lies beyond, this journey will go on, even if it never ends. If you enjoyed this journey, leave a like, subscribe to the channel, and turn on notifications. In a future video, we'll find out how long it would take to reach the center of the Milky Way, a destination even more mysterious and inaccessible than Andromeda, because in the universe, every answer leads to a new question, and every distance to a new beginning. Thank you for watching, and see you in the next video.